All right. Oh, what's going on here? Well, I don't see myself. I'm not quite sure why, but I'm here. You can see my name up on the screen. So let's see how many people are here right now. We have 25. I've forgotten how many people are in this class. I think it might be 30. So there might be a few people who haven't quite made it yet. That's okay. We'll wait a minute or so, but let's see. Let's get this open. So we got a lot. Yes, we have all these people are here. All right. Okay. No. All right. Well, first things first, can you all see what's on my screen? I haven't done this in a while. I want to make sure that it's working correctly. Yes, very good. All right. So at least that's working. For some reason, the camera part is not working. I mean, I see them on all, I can see the camera on this computer is working because the little light is on, but for some reason my face is missing. So I guess you'll be wondering what I look like. I don't know what the issue is. Technology is not my thing. So as long as you can see what we're doing and hear, that's the important thing. Now, this is being recorded. And I mentioned that in my announcements and in my emails, I believe. So let's do this. First, let's go over to Moodle and take a look and see what's there. You get started now. Probably most of your courses this semester are back in the classroom again. And originally that's what I thought would happen here too, but during the summer they kept saying, well, you know, maybe we'll do it, maybe we won't. And there's so much back and forth that I thought it would be easier to just stay online one more semester. You know, in some ways online is kind of a nuisance. It's not ideal, of course, but it seemed to work fairly well during the previous year from the fall of 20 to the spring of 21. So I figured we'll give it one more shot. And one of the great advantages of being online, of course, is that everything is being recorded. So if you miss something, you can just go watch the recordings. Whereas, of course, that's not true in the classroom, is it? No, it is not. So that's good because a lot of you have very tight schedules, especially those of you in the performing arts. And this way, you know that if you have to miss something, it's fine because you can just go watch the recording. It's not a real problem at all. So, but let's go to Moodle for a second and see what I've got there. So let's see, let me log in. And so for the fall, what I've done is I've posted, as you can see, the syllabus is already there. And we're going to start this course with chapter 5. It seems a little strange, but we're starting with chapter 5. There are 3 parts to it, A, B, and C. And all of them are right here. You can just download them and read them at your leisure. In fact, I encourage you to read them before the class starts so that you already know in advance what we're going to do that day. Because my suspicion is that many of you have not been in a math class for a while. And, you know, even if you love math, you still will get rusty if you don't use it on a regular basis. So in order to brush off that rust, I suppose, what you can do is go through here and take a look at these chapters and just remind yourself, because in chapter 5, at least some of this material is probably already familiar to you. There may not be anything 100% new here, but it's good to go back through it one more time. So as we go along, I'll continue to add more and more chapters, and always they'll be there ahead of time, so you can review ahead if you choose to do so. And I'll just keep piling them up in this Moodle, of course. And now, as far as recordings are concerned, now this is where it gets a little interesting. There's something about Moodle, it doesn't really have the ability to store large amounts of videos. Apparently, it isn't set up for that kind of thing. So luckily, I do have a YouTube account. I mean, it's not like it's a big deal. I mean, but this way, I can store a lot, and I mean a lot of material here. And so if you go to my name, Alan Anderson, your channel, what you'll see is that there's a bunch of videos here from past semesters. What I will do is organize the material into what are called playlists. Okay, so in other words, there'll be a playlist here just for this class. It isn't there yet because we just started, but it'll have this semester, MAT 1060, fall of 21, and you'll be able to go through and find that playlist, and then all the videos will be right there. So for example, if this was the spring, oh, okay, wait a minute. No. If this was the spring, you would come here and this is the list. These are all the videos that you can watch, and you can watch them at your leisure. They don't disappear. They'll stay there forever, as a matter of fact, until I delete them. And so you can watch them at your leisure. They're typical YouTube videos. They're fairly long, and you can watch them in bits and pieces or watch it all at once. And this way, you'll just see exactly what we were doing in class, just in case you missed something. All right, so we got that out of the way. So now the first thing we should probably do is look at the syllabus, so you know where everything is in Moodle. There are announcements here from time to time, by the way. I don't know if they are sending you an email when I create an announcement or not. It would be nice if they did. Sorry, but if not, you can come here and look at these every so often. Like, for example, I've got an introduction to the class here, where I basically tell you what to expect. Everything will be done on Zoom, as you can tell, 10:30 Mondays and Thursdays. You do have the capability with these microphones of asking questions. It shows up in the chat room. It's kind of an odd setup. What happens is it flashes a different color for about 2 seconds, so that I hopefully will notice it. And then there'll be a message right about here. And then I can either respond to you privately if that's what you want, or if it's a question for the whole class, you can just address it to the whole class, and then I'll either just verbally tell you what you want to know, or I can send it back to you through this chat room. Like if it's something that you only want me to see, there's a way of sending it privately, and then I can just type you a message. Okay, if it's meant for everyone, you can just go ahead and type it, or else you can even just say it out loud. Yes, so also, if you're not camera shy, you can turn on these cameras if you want me to know what you look like. Some of you are budding actors and artists and dancers and singers, and I'd be surprised if you were camera shy. It wouldn't be the best combination for your chosen profession, but if you want to remain secretive, that's fine with me too. I don't have to see you. This is like I said, this is a very artificial case, being online instead of in the classroom, and that's completely up to you. I would like you to see me, but like I said, the thing doesn't seem to be working today for some reason. It's funny because I've never seen that before. I've been doing this now for 3 semesters, and always this has worked. Something is just out of whack today. So I hope the school will be able to get that fixed. All right, so what else should we do? Let's go to the syllabus. Yes, that would be very helpful. Now, it's already on, as you saw, Moodle. Let me just give you some of the highlights. So here's the name of the course. There's my name and my credentials. It's an online class. There's no office as such, but you can send me emails. There's my email address. Also, by the way, I just want to mention that I have been using my own Google account to send the invitations. There's a reason for that. It's because it's easier to send out a large group of names. That for whatever reason, it doesn't seem to work with the purchase email account. So like, this is my Gmail account. And you would have noticed if you looked at it carefully when you got your invitation, it came from here. And again, it's because of the convenience that I can send out a whole batch of emails at one shot, which apparently can't be done, or at least I don't know how to do it on my purchase account. So you can either write to my Gmail account or my purchase account. If it's just a simple question or something like that, you should probably send it to my purchase account, because as you can probably guess, I get an enormous quantity of emails in my Gmail account compared to my purchase account. And so I'm less likely to miss it if you send it to my purchase account. When it comes time to handing in assignments, unfortunately, the only way we can really handle that is to have you send things to me by email. when that happens, sometimes the files get a little large and it might be easier to send it to Gmail, but we'll figure that out later. Now, there is a book that all my notes are based on the books. Now, the notes themselves are all on PowerPoint slides. This is what you need to get through the exams. In other words, all the material that we'll be doing is based on my PowerPoint slides. So you can get the book if you want it, but it's not necessary to pass the class. Let's put it that way, because what I've done is I've taken the material and turned it into my own notes. And so when it comes time to studying for these tests, this is what you'll be using. Okay, all the material will come from here. I won't just reach in and suddenly say, oh, here's this interesting thing on page 92 in the book. Let me throw that into the exam. No, it won't work like that. Now, the calculator. Now, many of you may not own a physical calculator, but it doesn't really matter because your iPhone has a wonderful calculator built into it. Now, if the camera was working, I would take mine out and show it to you. But sadly, again, it's really frustrating that just suddenly out of nowhere, the camera just isn't working. Am I doing something wrong? Let me just see something here. It shows the little icon. It shows everything that's supposedly working, but it's not there. Anyway, well, if you have your iPhone right in front of you, you can take it out. And wow, I don't know what to do about it. I really don't. You know what I'm going to do? Let me turn off the screen sharing for a second and turn it back on. Maybe that'll help. No. All right. Well, here's what I want you to do. If you have your iPhone, now, if you don't own a regular calculator, like let's say a Casio or something, on your iPhone, you do have an app built into it, which is a calculator app. So if you go search through your iPhone, you'll see it eventually. It just says calculator. And you may have seen it before, but here's the secret that you might not have known about. I'm going to show you something really exciting, or at least explain it to you. If you have that right in front of you and you're holding it in the normal position, you'll see it's a very standard basic calculator. But if you turn it on the side in the so-called landscape mode, you'll notice it suddenly switches into this very high-powered scientific calculator. Wow. Look at all those buttons. It has everything that you'll need for this course. Now, having said that, of course, you'll have to learn how to use it properly, and we will work on that throughout the course. I will explain to you what keystrokes you need to use to get the correct results, because I'm guessing that you don't use this on a regular basis. So by the time the semester is over, you'll have a very good understanding of how to use this thing. Now, if you do have a regular calculator, you certainly can feel free to use it. But if you don't, I think the next best choice is your iPhone. Okay. Now, if you have another cell phone, which I'm not familiar with all the other ones, like Android, for example, it probably has something comparable, but it may not be the same. So, if there's a problem, you'll have to let me know. But I think I'm going to assume that you have the iPhone. Now, if you don't, there's a couple of other options that I use on a regular basis. Let me just write these down for you. And if you have one of these, that's fine, because, we'll be able to get everything we want from here. I'm fairly familiar with the Texas Instruments series. This one is really a finance calculator. If you're not in a business program of some kind, you probably won't be using this one. But this next one is something you might have used in high school, the TI-83 or 84. It is a scientific calculator. It's a very large, complex calculator. But if that's the one you have, we can use that one too, because everything you need is built into it. So it'll be ultimately up to you. But what I recommend you do is pick one and stick with it. Okay, you should pick one calculator and get as comfortable as possible with it, and then use it for the rest of your life. You don't really want to get involved changing calculators, because it'll just confuse you. They're all different enough that you really have to pay attention to them. All right, kind of like going back and forth between a Mac and PC. Does anyone here routinely use both Macs and PCs, or do you tend to stick with one or the other? All right, well, I'll take that as a no. I do sometimes have to do both PCs and Macs, and I know it's a pain. Oh, there they are. I wasn't looking. Sorry. You guys are okay. Very good. I actually missed the chat room. Good. All right. But you get the idea. I mean, how awkward is it switching back and forth between them? Well, for some applications, the Mac is the better choice, and for some applications, the PC is the better choice. Like if you're studying graphic arts, is anyone here majoring in graphic arts or graphic design? Or even if you're not, you may have used software like Adobe Photoshop and that type of thing. And if so, typically professionals use the Mac version. Apparently it works better, or it is better suited for that type of application. On the other hand, if you're doing a lot of scientific modeling or anything along those lines, most likely you'll be using a PC, because the software in the PC was really meant for that kind of thing. Okay, so yeah, I just wondered. All right, so anyway, but you get the idea. So what I'm recommending you do is pick one calculator, possibly your iPhone, and then just using it all the time and getting very good at it. And of course, one of the good things about the iPhone is that you always have it with you, don't you? You ever leave the house without your phone? I don't think you do. You could forget your calculator, but I bet you'll never forget your phone. So therefore, that's what we want to do. All right, great. So that takes care of the calculator. And let's see, what else do we need to know? Well, there's all this discussion about the chapters that we'll be covering, what kind of topics we'll be doing. The purpose of these chapters is to give you topics that are useful in some important way, things that you might run into in other areas. No matter what you're studying, there's going to come a time when you have to understand certain types of concepts. For example, let me just pick one at random: interest rates. Now, you don't have to be an economics major to understand interest rates, at least at the consumer level. In other words, someday you'll need to borrow money to buy a car or a house, or you might get a credit card, or you might put money in the bank, or you might buy stocks. So you will need to understand how interest rates work, and that's part of Chapter 8, Consumer Mathematics. Statistics is the kind of thing that shows up in a lot of different areas, and especially if you go on to more advanced study, like in graduate school, sooner or later, statistics will be very helpful to you. So the topics were chosen because they're important, but also because hopefully they'll be useful to you as well. Even if you don't particularly care for math, you understand, I hope, how important it is. It's just one of those things that you have to deal with in this society. And the more understanding you have of these topics, the better off you'll be. All right. So it may not seem like it now, but I promise you, somewhere down the road, you'll benefit from having seen these topics. And, like I said, some of these you should have seen before. And some, they might come back to you very quickly. Sometimes they might not. But just the mere fact that we're doing math every week will help your brain find all this information that it has stored away somewhere. And it's just like anything else. Like if you've been away from something for a while, let's say that you are, for example, a musician and your main instrument is guitar, but you also want to keep up with the piano. Well, you know how it is. You neglect the piano for a while, your fingers get stiff, and you forget how it works. And so what we're trying to do is bring all that back, get you some good practice with math so that it seems comfortable and familiar to you. All right, we can't ask for anything more than that. Now, along the way, you'd be surprised. If you look at YouTube enough, you know that every topic under the sun is on YouTube somewhere. It doesn't matter what it is. Somebody has made a video. If you wanted to understand, for example, how pumpkin seeds grow or something. I mean, anything. It's going to have a video on YouTube. The same thing is true for math. Along the years, through the years, I have discovered several very interesting videos about math, which we will watch throughout the course along with the content. And it'll give you, I hope, a good feel for what this information is useful for. And the history of math itself is actually quite interesting. You'd be surprised. In fact, pretty soon we're going to watch an entire video about the number 0. And you might think, oh, no, it's interesting. You'll be very pleasantly surprised by how interesting it really is. And we'll understand how the number systems developed throughout the centuries. And so I'm hoping that by the time we're done, this will be an excellent experience for you. No matter what's happened to you in the past in math, this will be the time that math will actually be fun and interesting and useful. That's my opinion. Okay, so that's where we're headed. Now, sadly enough, we have to talk about exams. We have exams in this class, but you'll be doing them at home and sending them the results directly to me. So they are, in effect, take-home exams. Okay, so that's one of the good things about an online class. You can do everything at home, which means you can basically take all the time you need. I know that it's possible to set up exams online that are timed, but I just couldn't be bothered. I mean, there's no rush. It's math. If it takes you longer than somebody else to do it, all that matters to me is that you understand it, not how long it takes you to do it. So you'll have take-home exams, and so that should help, especially if some people are very nervous about math, and that should help reduce your anxiety if you know that you have plenty of time to do it. Now, if you do have to miss the class, like I said, the recordings will be available on my YouTube channel. I mean, obviously, you're better off coming than not coming. It's never going to be quite the same to watch a recording, but still, it happens. What are you going to do? Things come up and you can't come. That's fine. Just make sure that you keep up with the recordings, because otherwise you'll fall behind. In a class like this, you have to realistically avoid falling behind, because it's going to be tough to make it up if you fall behind in a class like this, because each week or each class builds on the previous classes. So some classes, maybe you can get behind a little and it's okay, but not here. I would think that in a class like this, falling behind is really going to be a problem. So just, make sure that anytime you have to miss class, that you do watch the video right away. Oh, did somebody try to send me a message that I didn't see? Oh, maybe turn on, you know what? I don't know if we have that capability. Closed captioning. It's one, yeah, I don't really know how that works. Nobody at the school ever said anything to me about that. You know what? I'm wondering if YouTube has that capability. I'll tell you what, I know you can't see me, but I am writing down on a piece of paper a note to myself, in which I'm reminding myself to find out if YouTube has that capability. It just might. You never know. Nobody's ever asked about that before. And I think it's a great idea. Although I must say, if you may have noticed, some closed captioning systems are not terribly good. You may have watched a movie in a foreign language and the titles are very... No, I don't. If they did, I don't remember them mentioning. They always send me a letter about, different things I should be looking out for, but I don't ever remember them asking about that though. So I will, yes, you can send them an email and ask them too. But I will also investigate this myself, because I swear this is the first time this has ever come up. I don't remember them ever mentioning it, but in fact, you know what, let's do this. While we're on the subject, does YouTube offer closed captioning? And it says Oh, sounds like it's saying yes. Oh, okay. Well, all right. So obviously I'm not going to spend the class time doing this right now, but I will definitely look into that. Thank you for asking because I never thought about it before. Um, so all right. So that's taken care of. Good. All right. So does anyone else want to ask any? Oh, yeah. I again, I don't. I'm good. I'm glad you know that. I may have to ask you when I read the instructions, but we'll see. I'll give it a shot. If I'll try an experiment with the first one, today's session, and then we'll see how it works. And if it doesn't work well, we'll try. But if I can write them myself, I mean, what I would probably do is let it try it and then see how well it works. If it doesn't do a good job, maybe I would update it myself. Okay, good. All right, now what else do we need to know? That's pretty much it. This is all legal language, blah, 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 blah. This is stuff that they insist on it being in the syllabus. All right, so now I know that today is your very first day back from a long summer. And so by the way, does anyone here have any other online classes besides this one? Or is this pretty much the end of the road for online? I don't know. I can't get anything out of the school. They're always telling me, yeah, maybe this, maybe that. Um, are you all pretty much back on campus? Oh, okay. Oh, so still, I'm not the only one. That's what I was really wondering about. Am I the only one who's still doing online? Okay. I honestly don't know what their intentions are. I think it depends on the COVID thing. I mean, if it suddenly gets worse again, they may have us continue to do online, but if not, it may be that we'll be completely back in person in the spring. So we'll see how that goes. All right. Anyway, so now it's the first day back. I think, though, that in spite of that, we'd like to at least get started. Oh, no, don't worry about that. No, no, no. We'll stop either on time or maybe a little early. Yeah, if and also if anyone needs to leave early for some reason, just go. I won't be offended. Just, sign off and go do what you have to do because I know some of you may be commuters and you may have a long drive after this class, and so that's okay. Just stay as long as you can, and then you'll decide when it's appropriate to leave. Um, yeah, that's okay. All right. So yeah. Anyway, so we want to get now. Of course, at the end of the summer, well, let's just say that you've been in a different frame of mind all summer. I mean, unless you've been taking a ton of classes, so it takes time to get back into the swing of things. For one thing, it doesn't really feel like the fall, does it's pretty much still the summer. Come on, it's not the fall. The fall starts in about 3 weeks. So we're going to build back up to this slowly. Okay. So I would like to begin with some very basic concepts, and we'll slowly, it'll be like wading into the shallow end of a pool before we get into the deep end where we can actually dive. All right. So we want to bring back slowly ourselves into not just math itself, but into school itself. In other words, college, the whole idea of being in college. It's like a very sudden transition. Last week you were on vacation. This week you're suddenly back in school. And it's a bit of a transition, isn't it? So we'll start with some basic ideas. This is chapter 5, which is the beginning of the course, as I mentioned. And so, like I said, most likely some of this will appear very familiar, but it's possible that you haven't thought about it for a long time. So we just want to get back into the swing of things. We don't have to get too carried away today, but I don't want to waste the period either. So let's start at the beginning of chapter 5. And we're going to be looking at the so-called real number system. The real number system. Okay, now you will recall that at some point in your math career, you illustrated the real numbers as a line of some kind. Let's say like, wait, hold on. Okay, what's going on here? Oh, there we go. Okay. I actually have a tablet here, which you can't see, which enables me to write directly on the screen, which is kind of cool. And then you would have had numbers like 0 and 1 and 2 and -1. These are the real numbers. And in between these numbers, you'll see there's actually an infinite number of values. Like, for example, here we'll have 0.2011, and here we might have 0.30752, et cetera, et cetera. These are the real numbers. Now, these are the numbers that we use on a regular basis, but there do exist other numbers besides the real numbers. So here's my challenge to you. Who remembers the name of the other numbers that are not considered to be real numbers? I'm going to give you a hint. It starts with an I. And there, oh, somebody's got it. Nice. Imaginary. That is correct. Imaginary numbers would be functions of the square root of -1, which is often abbreviated with the letter I. This is defined as an imaginary number. It does not appear anywhere on the real number line, although we're going to watch a video in which they explain to us where the imaginary numbers actually are relative to the real numbers. But the reason why I brought this up is because in this class, we will only be dealing with real numbers, okay? But it's good to know that the imaginary numbers exist. Now, you might say to yourself, what's going on here? How can we even have the square root of -1? You'd be surprised, I think, to discover how useful this really is. In certain areas like engineering, imaginary numbers pop up all the time. And in fact, in my pre-calculus class on Wednesdays, we do dive into this fairly quickly in the course. Which, by the way, if you've decided that you want to take more math classes when we're done here, which you might, the next logical step would either be statistics or pre-calculus, both of which I teach. Okay, so you never know when I might see you again. All right, well, anyway, so we'll go on. Now, the real numbers, there are many different classifications of real numbers. So we'll start with the very basic numbers, the natural numbers. Now, the natural numbers are the ones that were originally used by humanity to count things like how many chickens do I have? How many acres do I have? You know, these are numbers that were meant for one purpose, and that is counting. So these are sometimes called the counting numbers. This is what you first learn when you're a child. When you're first learning about counting, you're counting these out on your little fingers. 1, 2, 3, 4. Now, the way this is written, if you notice, these symbols, which are referred to in math as braces, are meant to indicate that this is a set, which we'll review as we go along, by the way. A set is a collection of objects, usually numbers, but not always. And if you notice, this is an unusual set because these 3 dots indicate that these go all the way up to positive infinity in this case. Which is designated with the symbol. Symbol. That cool symbol represents infinity. So in other words, the dots are there to indicate that this is a set with a pattern to it. In other words, 1, 2, 3, 4, followed by 5, 6, 7, 8, 9, 10, etc., all the way up to infinity. So the 3 dots are meant to indicate this is a pattern. And because there's an infinite number of possibilities, it's not possible to list them all. The correct name for this set of dots, by the way, this is called an ellipsis. You want to be very technical. This is an ellipsis, which means there's a pattern here. It's an infinite set that goes on forever. But you'll notice there's a lot of real numbers missing from this set. For example, there's no negatives, there's no fractions, and there's no zero. These are the first numbers that were invented by the human race. They're used for one specific purpose, and that's counting. When humanity started, especially getting involved with agriculture, it started to become important to keep track of how much, how much land do we have, how many farm animals do we have, how many bushels of wheat do we have, that kind of thing. All right, now, among the natural numbers, we can define something called factors. Now, the word factor is often used for many different purposes. For here, though, factors are pairs of natural numbers that have a specific product. So, for example, the number 12. Now, clearly, we can create 12 by multiplying 1 with 12, 2 with 6, and 3 with 4. If you notice, I'm only using natural numbers. So we say that 1, 2, 3, 4, 6, and 12 are the factors of 12. Okay. So already I can tell, don't worry, I can tell already that this is all coming back in a big flood into your memories, isn't it? You're thinking, oh yeah, I remember this. Yes, and in fact, I'm having very fond memories of this, am I not? Yes. Okay, what a blast from the past. Factors. When was the last time you thought about factors? Well, it's probably been a good long time. Even more than 2-3 years, who knows? It's been a while. It's like an old friend is coming to visit. Okay, an old friend you haven't seen in years. Factors make you cry. You mean with joy, right? Well, I'm glad to hear that. Well, don't you worry. By the time this class is over, those tears will be tears of joy, because you'll begin to understand how important these really are and how straightforward, really. Yeah, no, put away those old tears. We're going to replace those with nice tears, tears of joy. Okay. Yes. All right. So how about 24? Okay, well, here they are. Now, it's easy. When you make a list like this, you do have to be a little careful. You do not want to miss any. I do want to point out something. If you notice, for example, I don't have the order in which I do this doesn't matter. In other words, I don't need to separately write 3 and 8 with 8 and 3 because these mean the same thing. Okay, so these are all the factors. So therefore, we can say that the factors are 1, 2, 3, 4, 6, 8, 12, and 24 are the factors of 24. And that's it. There's no more. Now, here's an interesting fun fact. Each natural number has at least 2 factors. And what are they? I'm going to ask you this technical question right off the bat. And does anyone know what they are?
One in itself.
Yes, exactly. These two are, you must have at least 24 and 1 in this case. There might be more, but there have to be at least those 2. Now, this will help us. Oh, we're not quite yet. We got one more concept to look at here. The notion of being divisible, or sometimes you hear this referred to as evenly divisible. So for example, let me just show you that 10 is divisible by 2, but 10 is not divisible by 3. Why? Because 10 over 2 is 5 with no remainder. Okay, but 10 over 3 is 3 1/3. Or we could think of this as 3 with remainder 1. So therefore 10 is divisible by 2, because when you divide, the result is a natural number with no remainder. 10 over 3, no. There's that fractional part, or we can think of this as remainder 1. And so therefore, the purpose of this definition, the reason why it's here is because it means that a natural number is divisible by its own factors. In other words, if you're not sure if a number is a factor, you can prove it by saying, well, suppose I divide my number by this factor, does it give me back a natural number without a remainder? Okay, so the whole idea here is that a natural number is divisible by its own factors. So in other words, what this is telling me down here is that 2 is a factor of 10, but 3 is not. Of 10, okay. Nice. By the way, I forgot to mention this. Even though the slides are already posted on Moodle, the version that I'm creating for you right now with my own handwriting, I will add that separately so that none of this goes to waste. In other words, I'll give it a slightly different name, but this will become available on Moodle probably later on today. So that this way, let's say you missed something. I mean, you can watch the video and that's fine too, but this way you'll have a copy of all these notes with my own handwriting, because I'm hoping that this handwriting is giving you extra insight into these concepts. All right. Now we're ready for this is what I was about to build up to. This is a fun idea. And you hear about this sometimes, you may have forgotten about these guys, but there's a very special type of natural number that we want to define right now, and it is called a prime number. Prime numbers. Yes. How long has it been since you thought about prime numbers? Too long. Now, what does it mean to be prime? If the only two factors are 1 in itself, then the number is said to be prime. 7 is a perfect example. There are no other factors besides 1 and 7. Therefore, 7 is prime. Aha. Now, what about, let's say, 12? Is 12 a prime number? It is not. And here's why. Because it has factors, as we saw earlier, it has 1 and 12, but it also has 2, 3, 4, and 6. And so therefore, 12 is not prime. And in fact, you could probably reason out why none of them even, except for 2, the even natural numbers are never prime. Now, what about, oh, by the way, when anytime you make a definition in math, almost without fail, there could be exceptions that you have to watch out for. This one might seem a little odd to you, but it turns out that the number 1 is not considered to be prime. I'll tell you why, because the factors of 1 are 1 and 1. But the problem here is that to be prime, it has to have the factors 1 in itself, but the second factor here is not unique. In other words, it's the same number. So mathematicians will define 1 to be not prime. Okay, because in other words, it doesn't have 2 unique factors. That's really what the holdup is. Whereas with 7 is prime because 7 equals 1 times 7, but 7 and 1 are 2 different numbers. So formally, we will not consider 1 to be a prime number. Okay, it's a subtle point, but you just have to be aware of it. The prime numbers start with 2. Okay, so just remember that. Poor old number 1 is not considered to be prime. It sort of feels left out of the club. But here I made up a list of the first 10, and you look at them all and say, oh yeah, what do you know? They're all prime. Because what are the factors? Well, here's 1 and 2, 1 and 3, 1 and 5. And that's it. Now, somewhere along the way, we're going to see at least one video that mentions prime numbers. They have a lot of interesting properties, among them being that you might think that there's a formula that lets us generate all the prime numbers, but no such formula exists. In order to figure out prime numbers, computers have to just test them, basically. And that's very annoying to mathematicians. They like completeness. They like order, as you can tell. And the fact that there's no program, I guess you could say, that can generate all the prime numbers is very frustrating to them. It's just one of those things. You just have to keep churning them out and checking them all individually to see if they're prime or not. Now, here's an interesting side note about prime numbers. They're very, very widely used in this field called cryptography. They lend themselves nicely. Cryptography basically is all about creating codes. Now, here's an example of this. When you use Amazon.com to buy goodies with your credit card, what is it that stops hackers from reading your credit card number when you type it into your Amazon website? In other words, how does that information get to Amazon without hackers reading it and stealing your money? What is actually happening to your credit card number when you put it into that website? Well, it's being converted into a special code that only Amazon can read. So in other words, when you type it in, you may not realize it, but it's being converted into a very special, complicated code of some kind. And that's being sent off to Amazon, and their computers reinterpret it and convert it back into your credit card number, so that if hackers find this information, it doesn't do them any good because they don't know what it means. Like, in other words, if your credit card is 1, 2, 3, 4, 5, 6, 7, 8, 9, when it goes into hyperspace to get to Amazon, it might be XAB 21 3 star, something like this. And only Amazon knows how to turn it back into that credit card number. So it turns out the prime numbers are heavily used in these programs that are designed to convert numbers into codes for security purposes on the internet. I know somebody who works in this area. That's why I'm kind of a little bit familiar with this. And there's something about prime numbers. They just work well with this field. And so that's one of many cases in which prime numbers can be very useful in practice. So they're not just, fun. They are fun, of course, but they're not just, for academic purposes, prime numbers are actually useful in the real world. But anyway, what about the non-prime numbers? Like, what about numbers like 4 and 6 and 8 and 52 and 106, that kind of thing? What about the non-prime numbers? Is there a special name for them? The answer is yes. They're called composite numbers. All right. So basically, all the natural numbers have to be one or the other, except for one, as we saw. They all are either prime or composite. There is nothing else to choose from. It's just one that falls out of this category. It doesn't belong to either one of them. Poor one. Like I said, it doesn't seem to belong to either club. So, for example, 22 is a composite number because the factors are 1, 2, 11, and 22. That's 4. That's plenty. Therefore, 22 is defined as a composite number. All right. Now, we're going to do something interesting with these prime numbers. And well, this will take a few steps, but you'll see eventually it'll lead us to a very interesting result. So we're going to do something which sounds frightening. Don't be put off by the title. It's easy. Okay, we're going to consolidate what we've done so far and learn a new technique, which is called prime factorization. We're going to use prime numbers to create factors for natural numbers. Now, you've already seen that there's many factors for composite numbers. What we're going to be interested in, though, is that we want to create factors that are all prime numbers. Okay, so in other words, according to this fundamental theorem of arithmetic, every composite number can be broken down into a series of these, not just any factors, but prime factors. By the way, here's a helpful hint. Anytime in math you see something called a theorem, it's an important result. And if it's furthermore called a fundamental theorem, that means this is a huge deal. A lot of results depend on this being true. And so that means you're supposed to sit up and say, hey, wait a minute, this is important. Oh my God, is this important? Okay, so that's a helpful hint in math when you see results like this, theorem. Because if something isn't important enough to be called a theorem, sometimes it's called a lemma. You might recall that. It's just like almost like a little side note. A theorem is a full-blown result that can be proved for every case. And fundamental means that a lot of important results derive from this. So how does this work? Watch how easy this is. I'm going to show you a fun graphical way of doing this, by the way. A lot of math often can be reduced to geometry, it turns out, which means we can draw pictures that help us understand better these concepts. In fact, in the days of the ancient Greeks, who invented a lot of what we know today, they did everything pretty much in terms of geometry rather than algebra. So it can be done. So let's go back to our friend 12. Let's just randomly pick some of its factors, 2 and 6, 3 and 4. Now, 2 is a prime number, but 6 is not. 3 is a prime number, but 4 is not. Oh, somebody want to ask a question? Okay. So if we take 6, so let's say that we start out with 2 times 6 equals 12. What I would like to do is take all the composite numbers, composite factors, I should say, and break them down into a product of prime numbers. Okay, so clearly 6 equals 2 times 3. both of these are prime numbers. So what this means then is that rather than calling 12 2 times 6, I'm going to call it 2 times 2 times 3. And because these are all prime numbers, I'm going to give this a special name. This is called the prime factorization of 12. Because all the factors are prime numbers. Now, this is a factorization, but it is not a prime factorization. Okay, that's the important difference. Okay, prime. Now, here's the interesting part. There's only one prime factorization for each natural number. There are many factorizations, but there could be, but there's only one prime factorization. So in fact, let me prove that to you right now. So yeah, let's do it this way. 12 equals 2 times 6, or 2 times 2 times 3. We could also say that 12 equals 3 times 4, which is 3 times 2 times 2. But these are the same thing, aren't they? They're just a slightly different order. So no matter how I started, it's this part. Any way you look at it, this is the prime factorization. There's only one way to do this. It doesn't matter how I started, whether it's 2 times 6 or 3 times 4, I ultimately get to the same point. 12 is 2 times 2 times 3. Okay, and that's what we mean by being unique. There's only one way of doing this, and that's what the fundamental theorem tells us. So, well, you might say, well, so that's wonderful. What are we supposed to do with this information? Well, you'll see very soon one very interesting application of this. All right, now get ready for a blast from the past. This is a concept that you've seen before, but it may be buried in your subconscious because it's been a while. And it has two equivalent names, okay? So I'll mention them both. What are they? All right, you wait and see. Greatest common factors or greatest common denominators. It means the same thing. The book calls it greatest common factors, but it's the same thing as greatest common denominators. What does that mean? Yes, I knew it. You're getting flashbacks. Good flashbacks, right? Like Christmas is, no? All right. Well, that's what this class is for. We have to do something about this. We have to replace those bad memories with good ones. Okay. So it's the largest integer or natural number that evenly divides two different numbers. So let's start with 18 and 24. Okay. Let's just reason this out first. Let's look at 18 and 24. Are they both divisible by 2? Yes. Are they both divisible by 3? Yes. How about 4? No. 4 doesn't evenly divide into 18. No. How about 5? No. 6? Ah. Are there any more? 7? No. 8? No. 9? 10? 11, 12. I think we may have found it. So in other words, you could go through the entire list of natural numbers, but what you'll discover is that 6 is the largest natural number that evenly divides 18 and 24. Therefore, 6 is the greatest common factor, or the greatest common denominator between the two of them. And there you go. Now, you can see this was kind of a pain. Imagine if this wasn't 18 and 24, but 750 and 1022 or something. How long might this take, this process? A long, long, long time. We don't want to waste all day looking for greatest common factors, do we? Luckily, there's a technique we can use that'll speed things up immensely based on this our new best friend, prime factorization. Okay, maybe not our new best friend, but one of our new friends. We just met this person this semester, and we now are fast friends. And we want to use this friendship. How do we do that? Well, let me show you a graphical way of doing this. Actually, let me show you the traditional way, then I'll show you the graph. So remember, it's 18 and 24 that we're interested in. So these are two factorizations of 18. And what I can do here is rewrite this. In both cases, the prime factorization, I changed the order here, of course. The prime, any way you look at it, the prime factorization is 2 times 3 times 3. Okay. What about 24? All right. This one can be rewritten if you want as 2 times 2 times 3. Oh, no, hold on. Let's do it this way. Let me break it down a little differently. 2 times 3 times 4. Okay, in other words, and then don't stop until they're all prime. And here you've got 3 times 4 times 2. And then here you've got 2 times 2 times 2 times 3. So any way you look at it, the prime factorization of 24 is 2 times 2 times 2 times. If you want to speed this, you can write this as 2 cubed times 3 if you want to. But I want you to be able to see the individual factors. So what are we supposed to do with these results? Well, I'm going to gather them up on a single slide, and then we're going to see something very exciting. Which will speed this up immensely. Watch this. So bring them all together. Okay, so here's the prime factorizations. What we're looking for is the common, the product of the common prime factors. What do I mean by that? Well, these both have a 2, and they both have a 3. Therefore, the greatest common factor is 2 times 3, which is 6. Now look how quick and easy that was compared to having to list out all the different ways we can divide 18 and 24. The larger the numbers are, the quicker this will be. Okay. So we could save a ton of time this way. But there's even a more fun way of doing this, which involves a picture. We're basically going to draw a picture of a very special kind of tree. All right, so let's do that. This is good too, but I think you'll agree that the tree approach is very quick and easy. And it's kind of fun. I think you'll all agree that drawing is fun. Once in a while, when I say that, by the way, there have been one or two occasions when somebody in the class disagreed with that. They said, no, drawing isn't fun. And it made me wonder what kind of childhood they had. But no, we're going to draw these pictures. And the thing is, the way your brain is organized, pictures help you understand things, in my opinion, much more quickly than symbols. So what we're going to do is create a tree for each of these numbers, which will show you what the prime factorization looks like. Let's say we start with 18. Let me just randomly pick the factors 2 and 9. So this means 2 times 9 equals 18. These are the branches of a tree. Now, 9 itself could be written as 3 times 3. Now, the fact that all 3 of these numbers are prime means I can stop. The prime factorization of 18 equals 2 times 3 times 3. What about 24? Let's randomly choose 2 and 12. And by the way, I just want to point out that if I had started with 3 and 6 up here, I still would have gotten the same result. It doesn't really matter how you break this down, as long as you do it correctly and stop when you've reached all prime numbers. So here, for example, I started with 2 times 12. 12 is itself is 2 times 6. 6 is itself 2 times 3. And I know to stop now because all I have left is prime numbers. And again, the technique is to just pick the ones that they have in common, and you're done. And that's what we need to do. Ooh, that was easy. And even kind of fun. You get to express your artistic talents and have a little fun, and just look how quick and easy this was. Yes. Now, you may have had this question show up on the SAT. What's the greatest common denominator or factor of 18 and 24? I don't know if you got that answer right, but here, look how easy this would have been if you knew about this technique. I don't know if they still have the SAT or not, but when I was in high school, you had to take it, and it was verbal and math, 2 sections, and they both had maximum scores of 800. So that way you could tell somebody should be majoring in English or in math, or just, like if you have a very high math score, then you might end up studying math or, science or something along those lines. And if you have a high verbal score, you might end up studying something more creative. So anyway, so that's greatest common factors. Now, if you want to, you can certainly double check. It might always be sensible to double check. Like, for example, how do you know? What you might want to do at the very least is make sure that each of these does evenly divide by 6, and they do. And there certainly are no larger values for which this is true. So that means we must have done this correctly. Ah, okay. Wow. All right. So let's see. Do we have any others? I'll tell you what, just for the fun of it, why don't I have you on, I hope you have paper in front of you. Why don't you take out a piece of paper and apply this technique to 72 and 180. All right. I'll give you a few minutes and let's see how you did. Ooh, a little curveball there. You weren't expecting that, were you? No, that's okay. No, just because it's the first Monday of the semester, you have to be ready to think every day. All right. Does anyone have it? Okay, 12 is a possibility. Does anyone else have a different number? It's clearly 12 evenly divides into both of them. We also have a 36. Does anyone else have an attempt? All right, I'll tell you what, let's do it with my favorite graphical technique. We'll do 72 and 180. So it doesn't matter, but I usually end up starting with the smallest prime I can find and some other value just to get the ball rolling. You could have started with 24 and 3. It doesn't matter, like we saw. Actually, let me do it like this. I personally find it to be easier if I put the smaller number on the left. I don't know, that's just me. Okay, so the prime factorization is 2, 2, 2, 3, 3. Okay, and if you multiply that on your calculator, that is in fact 72. Then for 360, oh, sorry, it was 180. 290. And again, this is just my approach. You can do whatever you need, whatever, as long as and it will work the same way. Now, 45, we could try 5 and 9. Although again, we could have had 3 and 15. It doesn't matter. And again, stop when you have all prime numbers. So, and also when you write out the prime factorization, not that it's necessary, it's probably easiest if you write them from small to high. And what do we have in common? They both have 2 2s and 2 3s. Okay, there you go. So the greatest common factor is 2 times 2 times 3 times 3, which is 36. Yes, so whoever said 36 is absolutely correct. I see Daniel, Bravo, and Han. See, Sarah, 12 is a common factor, but it's not the greatest. Okay, so that's why that's not correct. But so yeah, and now in these slides here, I also have it done the traditional way where I just wrote them out. But I don't know about you, but I like the graphs. So anyway, so all right, well, I'll tell you what, it's the first day back. I think you're starting to get a sense of the excitement of this class, aren't you? And how much fun it really can be and how interesting it is. And you know, your memories are bubbling back to the surface of your math history. And so as we go along, we'll pile up on the techniques. We'll also start to learn more about the history of math. Like I said, I have a nice selection of short videos that we can watch to give you more historical background and more of a sense of what this information is good for. And I think you'll be pretty surprised, especially certain areas like graphic design depend very heavily on this stuff, because behind the scenes, that software is really just using a lot of numerical programs to accomplish your objectives. And anyway, so here's what we're going to do. So we'll stop right here. And you've gotten a good start to your semester, I hope. You're feeling pretty excited. And the only unfortunate thing is we have to wait till Thursday to come back. But in the meantime, what you should probably do is at the very least review chapter 5A and, you know, look at the syllabus, and we'll just pick it up again on Thursday where we left off. Sooner or later, I'll be giving you practice problems to work on at home. But right now, we'll just continue with this material. And, you know, in the early weeks, we'll be doing concepts that you might already know, and we'll be doing a lot of reviewing, I guess. And, but you'll see it's really interesting material. And hopefully whatever bad experiences you've had in the past, we can turn them around into something positive. So if you do not have any last minute questions, I guess I will see you all on Thursday, hopefully with the camera fixed. Otherwise, I'll remain that mystery person for the rest of the semester. All right. So, all right. Any questions so far? Oh, good. I mean, that's kind of my hope. I mean, it would be so easy to make this class as dull as, you know, dry as dirt or dust. I mean, but it is interesting, and it has a lot of fun applications. And I really think that's what we should be focusing on, really understanding why are we doing this, as well as understanding how to do this. So I'm glad that you like it so far, especially since, like, it seems like you had bad experiences in the past, and we want to make sure that that changes. So, all right, thank you for that. And anything else? All right, so I'll see you all next time then. And oh, one more thing, the video will be available on YouTube sometime probably tonight. I'll be in other classes all day, but sometime soon it'll be there if you want to look at it. Okay. All right. So goodbye.
Wait, real quick, are you still there?
Yeah, I'm still here.
Okay, yes. So in terms of the syllabus,
Uh-huh.
all I'm seeing on it is that we have, I just want to confirm, I'm not complaining, obviously. So we only have the midterms and the finals, right? There's no like, there's no homework or like.
No, what we're going to do is I'll give you problems to work on, and we'll practice. You'll do them at home, and then we'll work on them together in the classroom. They're really more for your benefit. I don't collect them because it's really more of a way of getting ready for the exams.
Yeah.
And making sure you're following along. So, you know, you'll be expected to do them, of course, but it's really just to find out if you understand the material or not.
Okay, perfect. And also in terms of the camera, I have an old Mac. It does the same thing. Like the camera becomes all gray like yours right now. So you just have to restart the computer and it should fix it.
Oh, okay. I'm glad you, yeah. You know what? You can feel free to give me technical advice anytime you want, because I'm not a technology person. I'm glad you mentioned that.
Yeah, I'm in the same boat. This Mac is like 10 years old. I'm using a complete piece of shit for this. But okay. Great first class.
Okay, I'm glad. I'm glad. Yeah, we always want to get off to a good start, you know, otherwise people will be like, oh no, what are we going to do? No. I want you to get the excitement right off the bat.
No, yeah, definitely. All right, yeah, I'll see you Thursday. Take care.
Okay, all right, bye.
Bye.
All right.